9.6, 40, you know what? That doesn't look like, that looks like one number. Okay, 9.6. What?
Tell them about your history.
Oh, history. I don't know I have history. I know. This is the one. I'm thinking about what the outer bound should be. Hold on.
Well, you're not doing 49 or 50 for your example?
We're going to do number 50 in a minute. We're going to do one of each because Wyckoff said that there were a couple of these, and we're making good time, really good time, which means we'll have plenty of time to do 10-1, 10-2, and 4. Okay? So I think it should be, I don't know, give me a number that doesn't suck. 3. Okay. Here's the deal with integration, double integrals. Is there? No, I just threw that marker away because it sucked. You just work from the inside out. So this integral is what I'm going to worry about first. First thing I'm going to do is I'm going to help you guys see how to see what you need to do. Hopefully this works. I'm only caring about y's because that should be y. So I'm going to put the x on the outside of this integral. I can put the x outside because it's a constant with respect to y and because it's multiplied by the entire function. Everyone okay with that?
Can't see.
Oh, of course you can't see. I'm in the way.
Isn't it 1?
Oh, I'm not done yet.
Oh.
Don't worry, for the final review, oh, by the way, I scheduled a final review. Up until now, I had to do it on my own time, and I charged people to come, so it was really fun. Last semester, I think I made $1,000 in a night. Booyah. Wow. I'm very good at my job. However, this semester, you're very lucky because I took a role from my last final review and conned the math department into giving me funding to be able to do it. So you get to come for free. Which is great. So, yeah, they're paying me. They're not paying me more. They can't pay me more. They have no money. But the point is that I don't have to waste my time. Like, it's not exhausting. Here's what you need to know. It's in 2 parts, part 1 and part 2, and we'll talk about it later after we get this done. What's the integral of 1 over y dy? Oh, from 1 to e to the x squared. Okay, well, you have to plug in your bounds before you go on. I want you to notice that this actually isn't too bad. They usually have something like this on there where you think you need to switch the bounds, but you don't. Is that okay? I can't even write. Oh, what point of what I was telling you. So we're doing a final review, and usually beforehand we do a big dinner. However, I can't possibly cook for 300 people. So I was thinking we should do an Italian-themed potluck.
Yeah.
And I was going to make a sign-up sheet online, and if you don't want to bring something, then bring like $1 or something to pay for all the people who are bringing something. Is that okay? I'll send out an email with all the info. Okay, what's the ln of 1?
0.
There we go. Okay, what's ln of e to the x squared? Yeah, this is the part most people mess up on. I'm going to show you in steps so that I don't have to show it 8 more times. Everyone with me so far? The x squared is a power and it can come outside. This comes out here, leaving me with an x cubed ln of e. What's the ln of e? No, it's not nothing. Nothing would be 0. It's 1. So then I need to integrate. That's very x cubed. I'm just going to add 1 to the power, divide by the new power, and I need to plug in my number. So 27/4, right? Oh, I'm sorry. Thank you. 81. Minus 0. So this is my answer. I've seen this type of problem. I can't remember what the bounds are, but they have this type of problem a lot. Now I think we should do number 50. Did you have a question?
Oh, no.
Okay. Yeah.
How do we know we don't have to switch the bounds because there's a variable?
You only switch the bounds when you can't integrate what they give you. Pretty much look for 49 or 50. If it's not those two, you don't need to switch bounds. Am I being clear enough?
Only switch bounds when the problem looks like number 49 or 50.
Or if it is 49 or 50.
Oh.
I thought I was being clear. Okay. I'm pretty sure that's number 50.
So smart. Is that a y over 2?
Yeah, that's a y over 2. Is that number 50? I thought so. Okay. How, hypothetically, if you actually cared about understanding this, I'm going to explain how you would. How come we need to switch to bounds?
You don't know.
Exactly. Our problem is if I integrate with x, I would need an x out front because if I do a u sum, my du is 2x. And I can't just put an x in, right? I just can't multiply by an x. A 2, I could put a 2 in and then 1.5 out front or something like that. But I can't make up an x. Everyone understand? Yeah. Beautiful. Okay. So because I can't do that, I'm going to switch the order. I'm going to do with y first and then with x. However, here's the rub. You cannot have variables on the outside boundaries. Everyone follow? So I can't just flip-flop those. So what I have to do is I just draw the boundaries. Okay? So let's start. I would have x equals y over 2, x equals 1, y equals 0, y equals 2. I'll just go right here. Okay, so first off, y equals 0 is this line. And I'm trying to make it really fat, but I only have one marker. Is this a fat marker? Is this a whiteboard? Yes, it's a whiteboard. I draw on the whiteboard in big. That's not a very good pen.
Good for practical purposes.
Oh well. Okay, y equals 2 is up here. X equals 1 is here. X equals y over 2. That's a little trickier. I know how to graph if it's y equals, so I'm going to multiply both sides by by 2. So I have y equals 2x. And that makes a line that goes right through there. Okay, the area we're looking at is this one. Because my boundary is 0, 1, this line, and 2. This line is not a boundary, it's just an axis. Is that okay? So now what I have to do is I have to read off my new boundaries. Y, because it's on the inside, has to have boundaries that have variables in it. So we're going to go from 0 to this line. What's this line in terms of x?
2x.
True, but we want it in terms of only x's. And then we need to go from here to there for x's. So just 0 to 1. Is that okay?
That's the hard part.
I think so too. Uh-huh.
How do you know to work up? One first and then go
How do I know it's not where?
How do you know to go from 0
Up to
0 to the line? Because I'm looking at that area. This is just an axis. It's not a boundary.
And you never go from like 2x to 1.
I never go from where?
2x to 1.
Well, we would have if y equals 0 wasn't a boundary. Does that make sense?
Oh, because you're doing dy?
Yeah, I'm doing with respect to y. And before my boundaries were from 0 to 2, and from 0 to 1. So, if I didn't have the y equals 0, then I would have used this triangle. But don't stress too much, you just need to know how to do this exact problem.
Okay.
Devin, you have a half question, I can feel it.
Is it, I thought when you had to switch around, you switch around also to make the two x's equal to each other to figure out your y.
That is, you could do that, except for, I'm going to just skip that because it would take a long time to explain. If you want to ask me that tomorrow in the lab, I'm happy to show you. Okay, so now that I have this, I'm going to integrate with respect to y. So I have e to the x squared y. I need to plug in my bounds for y. I'm going to simplify it just a touch. Do you guys get the email I sent with the link to my YouTube channel? Okay, I'll just send it again tonight. Okay. So now that I have that, I'm going to do a u sub. U equals x squared du equals 2x dx. Could it be more perfect? I don't think so. So from here, I'm going to go e to the u du. And then I'm going to integrate that, which is just e to the u, which is e to the x squared. And I need to evaluate from 0 to 1. Is that okay? I'm going to put the 1 in. And minus the 0 in. So I get e minus 1. You can at least remember that much, right? True. You can recognize the problem. You remember the answer.
Yes.
I believe you could do that.
I believe so.
Okay. That's what you need to know from 9.6. We're going to rock on to